Hello, this is College Algebra, Lesson 9.4. They're going to ask you about symmetry. Symmetry is really easy to distinguish. You just have to be careful that you remember the little details. Number one, to test for symmetry about the x-axis, you replace y with negative y, and if you get an equivalent equation, then it is symmetric. Number two, same process for y, you're just reversing the letters. To test for symmetry about the y-axis, replace x with negative x, and if the equation is equivalent, then it is symmetric. Now, for symmetry about the origin, if it is symmetric about the x-axis and the y-axis, then it is symmetric about the origin. So it's not too difficult at all. So let's look at some problems. Question number one that I pulled from your homework says, without graphing, determine whether the following equation has a graph that is symmetric with respect to the x-axis, the y-axis, the origin, or none of these. So to test for symmetry about the x-axis, I replaced y with negative y. Now you'll see that this function takes your y value and squares it, your entire y value, the y and the negative sign. And when you do that, you get y squared. So if this were 3 and you replaced it with negative 3, the result will be the same. So you do get an equivalent equation. So yes, it is symmetric about the x-axis. So we check yes. To test for y-axis symmetry, I replace the x with the negative x. This function also squares the x term, its sign included, so we get x squared plus y squared. It is equivalent, so yes, it's symmetric about the y-axis as well. Now, since it was symmetric about the x-axis and the y-axis, it's automatically going to be symmetric about the origin. Number two says determine the symmetries, if any, of the graph given this relation. So it says y equals x squared minus 2x. If I replace x with negative x, or if I replace y with negative y, those are my situations. So number one, I want to check for symmetry about the x-axis. So replace y with negative y. When you do that, you do not get an equivalent equation. So it's no on x-axis. So that's going to knock out origin because x-axis is gone. But I do need to check on y-axis. So I'm going to check for y-axis by replacing x with negative x. So y equals negative x squared minus 2 times negative x. Now, it's not going to change anything here. It's going to square it, and you're going to get the same number back. But this one is not squared, so it is going to give you a different value. So this one's no as well. So no symmetries apply. It has none. Number 3. Use the test for symmetry to decide whether the graph of the given relation is symmetric with respect to the x-axis, the y-axis, or the origin. More than one of these symmetries may apply, and perhaps none apply. So, number 1, for the x-axis, replace y with negative y. So this is going to be negative y equals 4 times the absolute value of x. That y is negative now instead of positive, so this is no. It's not going to work here. Number 2 says we're checking for the y-axis, so I'm going to replace x with negative x, and when I do that I get y equals 4 times the absolute value of negative x. Now absolute value works kind of, well, it changes the sign, it doesn't square the number, but it does always produce a positive result, whether you have a positive number inside or a negative number inside. So this one's going to produce an equivalent equation. So this one's yes. So it is y-axis, and it's not origin because we got a no up there. So it's respect to the y-axis, not the x, not the origin, and not all three. Number 7 in this section says determine the open intervals over which the given function is increasing, decreasing, and constant. And all you have to do is look at your graph, and they're talking about the domain, so they're going to want to know what x values is this interval increasing. That means going up. Okay, going up. Well, you have to be careful because of those arrows they have on there. They're a little bit misleading, but this is going up. It's getting, as it moves from left to right, the values get higher. So this is where it's increasing. From negative infinity, that arrow just means it continues forever, all the way to right here at negative 4. Negative infinity to negative 4. And then the next question says, on what interval is the function decreasing? That means as you move from left to right, the values are going down. The graph is going down. And you can see that's happening over here. It's decreasing from here at 0 all the way to positive infinity. And then when is it constant? That's the flat part of the graph. It's constant from negative 4 to 0. Okay, I think that takes care of the skills in 9.4. So I'm going to stop this video and then I'll make one for 9.5.